Hello, welcome back to this video series on program synthesis and SMT solvers. Today I'm going to continue my discussion on computing the average of two numbers, but rounding to the seal. Okay, what I mean by that is, in the previous video, we talked about computing x plus y by 2, right? But we rounded it to the lower value. For example, if the answer is 5.7, we round it to 5 instead of 6. Okay. In this video, we will solve the problem of average again, but we will be rounding to the upper value. If the answer is 5.7, we will round it to 6. Okay. Instead of going down, we will go up. So I'm going to use program synthesis technique for this problem. However, I'm going to leverage the answer or the model we synthesized from this particular problem. So it's like an abstraction. I would like to make use of whatever I have already synthesized to synthesize new expressions. So that's my plan for this session. I will show you now my implementation, how I can synthesize that very quickly. So first, let me run the average synthesizer that we talked about in my previous video. It may take 1 minute or so to get the average synthesized. This is doing a regular average to the floor. Okay, add two numbers and divided by 2 without creating overflow, of course. Okay. Once the model is synthesized, we can leverage it for solving the other problem. It should come out anytime soon. This is computing the average of two numbers. Now we have the average of two numbers. We can just take this and use it as part of the new synthesis. Okay, that's the goal for this video session, is to show you how I can synthesize now the seal function. Okay, as you can see, I already copy and pasted the same synthesized version, but we can double check it's the same. Yeah, it's literally the same, no difference whatsoever. Okay, so I will leave out this part. We don't need this, right? So this is the synthesis program. The goal is now to synthesize a seal function, right? You average to the seal. However, as you can see, the grammar remains the same as the other one that we saw earlier. However, I'm adding a new operation, right? You average, which is a function that we already synthesized. So we can now leverage this as part of the seal function synthesis. That's the point of this video, is to show you that you can put functions that you already synthesized as part of the grammar. Okay, so let's give it a try and see whether we can get out average seal synthesis. Okay, it should be much quicker now. We will see. Yes, as you have seen, the program has synthesized this version, right? This is basically the definition of average. Let me write it. If we call this as the function f, right? This is the function f, which is computing the average of two numbers without causing overflow and rounding up to the higher value. What is the program that we synthesized? We synthesized this program, right? This is the program. This is the program, which is nothing but average. We call the u average function, right? Which takes this and then it does the bitwise knot of y, and then it puts a minus in the front. So this is basically the U average call, right? It's going to call the U average function that we already synthesized, passing these two arguments. Okay, as you can see, we basically built an abstraction. We solved one problem using other problem. All right, that was much quicker because average was already codified as a function. But there is still a question of how do we know this is correct and so on, right? So what we can do, of course, is if we know formally what is the meaning of average and what is the meaning of seal, we can define a formal specification and then compare against this derived or synthesized model. What I'm going to do though is slightly different. So I'll show you what I did. I actually synthesized this by examples, right? I constructed a bunch of examples, you know, ceiling of 6 and 4, average is 5. On the other hand, 3 and 6, of course, is 9. 9 by 2 is 4.5, but we need to go up, so it's 5. So I constructed a bunch of examples. I'm not claiming they are complete or not redundant, but seem to be a good collection of examples to synthesize something meaningful. Okay, that's always a risk that your example is not complete, but that's a different topic. Then you have to sort of do some analysis on the synthesized program to figure out whether your examples are good. So let's consider this problem that we comment out this average, right? We don't use the average anymore. And let's synthesize a new expression, which is going to take some time now because we are not using the abstraction. We are directly going down to the lower level functions, right? And what I'm going to do is I'm not going to hold you until the video, until the output is coming. So I actually copied the output in my run. So what I'm going to show you this. So this particular function uses the average. As you can see, it's using the average, right? The average is something that we already synthesized, okay? And this is the average seal, which uses the average function, okay? But then I also went ahead and synthesized something without using the average, right? I call it average seal spec, which is basically removing that U average from the grammar and synthesis this. And now I'm formally verifying whether this one that I have highlighted, right? This one is the same as this one, okay? Just to be more confident, okay? Are these two things the same or different? We can check it formally by doing an assertion saying that there doesn't exist any assignment variables, any variables X and Y, such that these two things are different, okay? That's what I'm verifying here, okay? So this one comes out to be very quick. We can very quickly check this. Okay. Well, I'm going to do this very quickly. Language is SMT2 and the program is this. So as you can see, it says unsat, meaning my assert was always false. In this case, assert being always false is good. Okay, why is it good? Because this particular statement must be always true, which is what exactly we are looking for, right? We want to make sure that this seal, which uses the average function, is the same as the other seal function, which doesn't use the average. So they both are the same. Okay, we formally verified it. So what is the main point I wanted to convey to you is that if you have already synthesized a program like an average program here, right? Average function, you can leverage that as part of synthesis of new things, and it's much more fast than solving all the things from the bottom up. Okay, all of these are low-level operations, right? Here it's kind of abstracting it, and once you solve it, you avoid some of the space explosion problem in the synthesis effort. I hope you find this informative. Thank you very much.